All right, let's get this going. So Unit 9, Day 2, Chemical Reactions, Balancing Chemical Equations. One of my favorite things. Okay, so let's just jump right into it. The law of conservation of atoms. There must be the same number of each type of atom before the reaction as after the reaction. So basically, you'll have the same amount of atoms on the reactant side, and after the reaction takes place, yields the same amount of atoms on the product side. Remember, matter cannot be created nor destroyed. So, coefficients. That's the number in front of a compound or an atom. Are numbers, so coefficients are numbers that go in front of each substance to indicate the number of atoms or molecules that are reacting or being produced. So we're going to try some examples, and I'm going to show you what I'm talking about with the coefficients, okay? Examples, smiley faces. And we're going to use something called the tally method to balance equations. And I'll show you what that is. So, example. We have aluminum and sulfur reacting together to form aluminum sulfide. So let's balance this equation. If I give this on your piece of paper, you're going to see that there's 2 aluminums on the product side and 1 on the reactant side. This is not balanced. Sulfur has 1 on the reactant side and 3 on the product side. So let me show you the tally method. Write down underneath your yield sign what you have on both sides of the chemical reaction. So we have aluminum and we have sulfur. Now tally how many you have on the reactant side. I have 1 aluminum on the reactant side and 1 sulfur. I have 2 aluminums on products and 3 sulfurs on products. Obviously, that's not balanced, like I've already said. So let's write that in. Oh, excuse me. I need to balance my products and reactants. So I have 2 aluminums on the product side. I need 2 on the reactant side. So let's just go ahead and put 2 on the reactant side and see what happens. So I'm going to draw 2 in. Now I have 2 aluminums and 2 reactants. So fix your tally system. Cross out the 1 because now you have 2 and write in 2. Do the same thing for sulfur. 3 on the products. So add 3 on the reactant side. Cross out what you used to have and write in what you got now. Is it balanced now? It sure is. You have 2 aluminums and 3 sulfurs on each side. So basically, if the numbers match on both sides, you're balanced. Let's do another example. Same thing. Write down beneath your yield sign what you have on both sides, and then tally what you got. I have 1 lithium reactant, and I have 2 oxygens. How many do I have on the product side? I have 2 lithiums, and I have 1 oxygen. Obviously, that's not matching, so let's add 2 lithiums to the reactant side. Cross out and write what you got. So that now matches. Let's try to fix our oxygens. Well, if I add 2 on the reactant side, that's just going to make it even more oxygen on reactant. So I'm going to have to go to the product side. I'm going to add 2 oxygens on the product side. So now I have 2 oxygens. So now that matches, but look, I changed my lithiums. On the product side, I now have 4 because the coefficient 2 times 2 lithiums gives me a total of 4. So let's switch my reactant side to 4 lithiums, cross out 2, put in 4, and let's see if we balance. Whoop, too much. Yes, we do. We have 4 lithiums now, and we have 4 on the product side. Remember, this 2 and this 4 are the coefficients. I didn't mention that in the last example, but These are the coefficients I was talking about. And then 2 times 2 is 4 on the product side, lithiums. And over here, I have 4 times 1. There's 1 lithium. So 4 on the reactant side. I have 2 oxygens, because there's a little subscript here is 2. And on the product side, I have 2 oxygens with no subscript. So it's just 2. Let's do another example. Oh boy, look at all that. Write down what you have. We have iron, we have sulfate, we have sodium, and we have phosphate. Do not break up your polyatomic ions. Leave them in parentheses. Do not break them up, or else you will have some problems. Write down what you got on both sides. I have 2 irons on the product side. 3 sulfates. This subscript 3 goes with this whole parentheses here. This subscript 3 goes with the polyatomic ion sulfate, which means I have 3 sodiums. And how many phosphates would I have? Just 1, because there's no subscript right here. Let's do the same to the other side. I have 1 iron on this side, 1 sulfate, 2 sodiums, and 1 phosphate. So I'm not matching. Which one should we go with first? I'm just going to start at the top and say, let's go with the iron. I'm going to put 2 irons on my product side so it matches my reactant side. I'm going to draw that in. But what else changed? I changed my phosphates. So let's go ahead and do that. I now have 2 phosphates on my product side. What did that change? On my reactant side, I now need to balance out 1 to 2, but I'm still on my product side. So what else do I need to balance over here? I need 3 sulfates on my product side compared to my reactant side. So let's go ahead and put that in and fix it. So now I have 3. So now I'm matching, that's good, but I'm not matching with my sodiums. But I already put a 3 coefficient in front of my sodium, so let's see what happens when I change that. 3 times 2 is 6. So now let's see my reactant side. I need 6 sodiums to match my 6 sodiums on my product side. So let's just put that in. 2 times 3 is 6 sodiums. So now where iron's matching, our sulfates are matching, our sodiums are matching, our phosphates not matching. But let's see what that 2 coefficient did. 2 times 1 phosphate will become 2 phosphates. Now it doesn't match. Let's see. We have 2 irons, we have 3 sulfates, we have 6 sodiums, and we have 2 phosphates. So are we balanced? Yes. Happy face. We match our reactants match our products on both sides. So as you can tell, it's kind of a process of elimination. Whatever you change, you need to do so to both sides, which is why we have this tally system. So as I've already said, as a helpful tip, do not separate your polyatomic ions. Remember, these are your polyatomic ions, the ones that are in the parentheses, the ones that are on your polyatomic ion sheet, and some of them are on the back of your pink periodic table. Yes, you may use your polyatomic ion sheet when necessary in our class. We'll never take that away from you, except on the EOC, but the EOC will only use the polyatomic ions on the back of your pink periodic table. So let's go ahead and try out the worksheet.